Okay, problem 11 is the classic diving board problem. You got a diving board, there's somebody standing here out at 4.5 meters. There's a support at this end, there's a support 1.5 meters in. The question is, what is the force on each one? I'm going to call this FL and call this FR, right? And then we've got the weight of the diver out there, which is 580 newtons. Um, and the board itself has negligible mass, so we're going to ignore that. All right, and so we're going to do two things. We're going to add up the forces, right, and they have to be 0. And then we're going to add up the torques. I'm going to add up the torques about the leftmost point, so F left is not going to be part of the equation. All right, so to begin with, this is a statics problem. So sum of the forces equals 0, and so that's F left plus F right minus 580 newtons. Okay, so that's just the sum of the forces. I took F left and F right both to be vertical, upwards. All right, both to be going upwards. And then part 2, sum of the torques also should be 0. So F left is a distance 0, right, from the pivot point, which is at left. F right I took to be up, and so that would be a counterclockwise pivot, so that would be positive. So F right times 1.5 meters, right? Now the weight all the way out at the end, that's downward, that would be a negative torque, so that's minus 580 newtons times 4.5 meters. All right, and this gives us, we can solve this right away. For F right is 580 times newtons times 4.5 divided by 1.5. That's what, 3. So 580 times 3. 580 times 3. So 1740 newtons is F right, and it is directed upwards. All right, so magnitude of part C 1740 and part D upwards. All right, if we stick this then into this first equation, the sum of the forces, we're going to get 0 equals F left plus 1740 minus newtons minus 580 newtons, right? And so F left is going to be 580 newtons minus 1740 newtons. F left is going to be 580 minus 1740 is minus 1160 newtons. And so that tells us the magnitude of the force on the left one is downward, all right, downward, and that the magnitude is 1150 and it is directed downward, right? So which pedestal is being compressed? The right pedestal is being compressed, right? The force the right pedestal is providing is upwards, and that means that it is being compressed because it is reacting to the downward force of everything else, right? And on the left, the force on the left hand side is negative, which means it's providing a downward force, which means it is being stretched. Okay, let me just note compressed and upward, stretched and downward. And that's it for problem 11.